These are the frequently asked questions for section 1-1, day 3. Number 48 has us connecting graphs and equations, and it says the curves on the graph below are the graphs of the three curves given by y sub 1 is 4x plus 5, and I notice that's linear, so that has to be the black graph right here. Wait for the smartboard to decide this is okay that I am writing on this. The second curve, I have a cubic, and that one has a leading coefficient that is positive. So we pick out which one that would be, and that positive leading coefficient would make that the red graph, y sub 2. And then the negative leading coefficient would have n behavior approximating what we see in the blue up here. So we have for A, write an equation that can be solved using the points of intersection of the graphs of y sub 1 and y sub 2. You have to think graphing calculator-wise on this one and think, well, that would happen if those two equations are equal to each other. So if 4x plus 5 equals x cubed plus 2x squared minus x plus 3, that's when we would find their intersections. And then we would go ahead and move everything over to one side. So we would subtract an x cubed. I'll just go ahead and write down subtracting that. Subtract the 2x squared, add the x, and subtract the 3 to move everything over. And then we combine like terms. And we have a negative x cubed minus 2x squared. A plus 4 plus x is plus 5x. And then we have a 5 minus 3 plus 2 equals 0. And you should have a deja vu moment because you realize, hey, wait a minute, that's y sub 3. That's what that is. And that's why they wanted us to look at this problem, was to see that that is truly what is going on. Then B says, write an equation that can be solved to find the x-intercepts of the graph of B. Of actually y sub 3 is part B. Well, that's just the zeros. So all we have to do is put a 0 right there. So that would be negative x cubed minus 2x squared plus 5x plus 2 equals 0. So some of you are doing some serious overthinking on this problem. But you know what? We tend to think there must be an algebraic way for us to do this. There is, but the thinking on this one really needs to be, if I were to use my graphing calculator, what would happen here? Part C, writing to learn. How does the graphical model reflect the fact that the answers to A and B are equivalent algebraically? So looking at the graph, they're saying, how could we know that that was going to happen? And when they ask you to look at a graph like this, what you want to do is think horizontally and vertically. So vertically, those intersections, we wouldn't notice anything. But if we make vertical lines at the x-intercept of the blue graph, which was that final cubic down there that had a negative leading coefficient, we notice that that lines up vertically with the intersections of the other two graphs. So that's what we need to say. We say that a vertical line through the x-intercepts of y sub 3 passes through the points of intersection of y sub 1 and y sub 2. That's what we notice graphically. If you draw those vertical lines, that just happens. They line up. So D says, confirm numerically that the x-intercepts of the third, y sub 3, the third equation we find up there, give the same values when substituted in the expressions for y sub 1 and y sub 2. So what that means is, because they lined up vertically, their vertical coordinate, which of course is y, should be the same. So I have this graph in there in the calculator already just to save some time since the calculator really slows down the process. And I'm just going to hit zoom 6 and we'll see what we can get from this graph. And it happens that's a pretty doggone good look to figure out what those x-intercepts are. So second and trace, number 2, we want to find the zeros. So let's get Blinky in position to get that leftmost 0. And he would need to be above the x-axis in order to be to the left of that. Press enter. Move Blinky below the x-axis, hit enter, and enter through guess. So that one we find out is negative 3.323404. So we would write that down. And then we go back after the other ones. So back to the calculator, second trace, number 2. And move Blinky into position for the middle x-intercept. We're going to need to be below the x-axis to be to the left of it, and then above it to be to the right of it, and hit enter through guess. And for that one, we have a negative 0.3579264. And one more time. Second trace, and we need number 2, and we'll move this into position, and this time it needs to be above it in order to be to the left of the intersection, and then arrow to the right, and enter through guess, 1.68133306. So here's what we're saying. This is x for both of the equations that they gave us. What we want to do is find out what is y for both of those. And what we should see is that we get the exact same number for both y sub 1 and y sub 2. That should work out to be, and we know that because we know these line up vertically. Now I will just do the first one for you. I'm not going to do all 3 of these because this is just punching it into the calculator, so you'll be able to do this. Our top equation, that was the 4x plus 5. So we need to go back to the main screen and say, okay, what's 4 times, and I'll do the first number up there, which was negative 3.3233404. Negative 3.323404. There we go. And then plus 5. And that comes out to negative 8.293616. All right, I'm trying to punch this one in with the equation that's underlined in the red here. Every time I do, the calculator is moving so slow that it is not punching in what I am punching in. So I'm going to give this one more try and get this thing out of the way here so that we can see that equation, which is this one. All right, so away we go. Parentheses, negative 3.323404 parentheses 2 the third power. And we need that plus 2 times parentheses negative 3.323404 parentheses squared minus parentheses negative 3.32304 plus 3. And there it is. We get exactly the same answer that we had when we punched in 4 times negative 3.323404. So this is not a pleasant experience to do on this emulator, on the smartboard, because my computer is running so low on memory that it takes forever to get these answers. But we would go back and write down what we see on the calculator. So negative 8.293611902. And because of that, I'm not going to do the next two for you. It'd be a lot easier for you to punch those in and take a lot less time. And at the same time, I will be able to turn off the smartboard emulator to do the other questions that people had. And that way this video won't end up being a half an hour of just watching me punch things in. So I'm going to turn off this and get to the word problems from the worksheet. And again, it takes the smartboard just a second to realize, hey, I'm shutting that off. And move to the next one. All right. So the next problem that you had asked about, you needed 2, 3, and 4 off of the worksheet. And number 2 says we have a movie star that's unwilling to give his age. He posed the following riddle to a gossip columnist. 7 years ago, I was 11 times as old as my daughter. Now I am 4 times as old as she is. How old was the actor at the time who posed the riddle? Well, your first decision is going to be, are we talking about now, or are we going to think of this from the past? And I found this to be easier to think of from the past and say, the movie star's age is X. And Y will be his daughter's age. So in the past, his age was 11 times his daughter's age. But now 7 years have passed, so his age is X plus 7. And now he said he's 4 times as old as she is. And she is now 7 years older as well. So let's simplify this bottom equation. X plus 7 equals 4y plus 28. So X will equal 4y plus 21. And now I'm going to use some substitution because X equals 11y. So wherever I see an X, I can put 11y. But notice I'm going to be finding the daughter's age, so then I'll need to work backwards. This is just a little nicer math than doing it the other way. Subtract 4y from both sides and divide. And we have 7y equals 21, so y equals 3. And we go back and realize, okay, so that means 3 times 11, that's 33. So X equals 33. That was 7 years ago. So now, 7 years later, the actor will be 40 years old. So what we want to do is pull this together and interpret what we found. And our answer would be the movie star was 40 when the riddle and the smartboard is not catching up with me here was answered. So there it is. All right, on the next page, we have another one where we're talking about basically fill rates. Next door neighbors, Luke and Charlie, use hoses from both houses to fill Luke's swimming pool. They know it takes 18 hours using both hoses. They also know that Luke's hose, used alone, takes 20% less time than Charlie's hose alone. How much time is required to fill the pool by each hose alone? So here's what I'm thinking. This is a rate, and it is pool per hose. I mean, really, that's what we're talking about here. So when we're looking at this and we're trying to find a total, we want to know if you have your total of it takes 1 pool 18 hours using both of those hoses. That's your total. One pool in 18 hours. Well, then we have Luke's hose. And we know that Luke's hose used alone takes 20% less time than Charlie's hose alone. Well, we don't know anything at all about Charlie's hose, so we'll make that X. So X is Charlie's hose. In addition to that, they're also using Luke's hose. And what we have here is that it takes 20% less time than Charlie's hose. I mean, it's great that they're telling me that it's 20% less, but I want to know how much time is it of Charlie's hose. So if it's 20% less, then it's 80% of the time that it takes Charlie's hose. So I'm going to put 80% X down there. And then the next thing to do would be to figure out your LCD for the 0.8 and the 18. And to do that, even if it's not the LCD, I would just take 18 times 0.8. So our LCD is 14.4x. So we have to multiply every term by 14.4x. And when we do that, we get some math that's not too doggone awful. So over here we have our 1 over 18, and we multiply that by 14.4x, and that gives us 0.8x. Over here the x's will cancel out, and we'll get 14.4. Over here the x's will cancel out, and we get 14.4 divided by 0.8, which is 18. And then we go ahead and add those two numbers together and get 32.4 and divide by 0.8, and x is 40.5. So 40.5 hours was, remember, Charlie's hose. So Charlie's hose is taking 40.5 hours. So if Charlie's is taking 40.5 and Luke's is 80% of that, we could go ahead and take 40.5 times 80%, so 0.80, and that gives us 32.4 hours, and the smartboard is not with me again. Let's give it a second to figure out what it wants to do. Okay, looks like it wants to behave itself again now. So we're going to get 32.4 hours, and that would be Luke's. All right, so let's put this all in a sentence. It would take 32.4 hours of Luke's hose and 40.5 hours of Charlie's hose. Because the question was, how much time is required to fill the pool by each hose alone, separately? And that's what we were finding. And the next problem is, a salesman in Germany drives from something I'm not even going to try to pronounce there, to someplace else I'm not going to try to pronounce, a distance of 120 miles at a steady speed. He then increases his speed by 10 miles per hour to drive the 150 miles from those two towns again, different towns. If the second leg of his trip took 6 minutes longer than the first leg, how fast was he driving between the town that starts with a G and the town that starts with an S? So the first thing I noticed here was, 6 minutes? 6 minutes is 6 out of 60, or 1/10 of an hour, because the rest of the information is in miles and miles per hour. Now, it said the total distance, we've got 120 miles for the first trip. So 120, that's going to equal some rate and some time. That's going to give us that. And then for the other trip, it says they go 150 miles. But this is the good news. They talk about how that compares to what was done in the past. Increases the speed by 10 miles per hour. R is 1 plus 10. And we take a look at this. They say that the time took 6 minutes longer, so it was the same time, but with 1/10 of an hour added to that. So just like we did this one in class, what we would do is we would clean up the bottom equation and do FOIL on that, and that will be r sub 1 t sub 1 plus 1/10 r sub 1 plus 10 t sub 1 plus 1. We would subtract 1 from both sides, so 149 equals, and then we take a look at what we have over here that could be put together, and we realize there's really nothing else we can do with this mess right now. So then, what to do? Well, a couple of things. You might say, first I want to multiply this whole thing by 10 to get rid of the decimals. Or you could say, you know what, I'm going to do some substituting in here because I haven't used my first equation yet. So if we're solving for r sub 1, it would be 120 divided by t sub 1. So 149 equals 120 over t sub 1 times t sub 1 plus 110 over 120 over t sub 1 plus 10 times t sub 1. So what I'm going to end up finding here is time. So I just keep going and figure out what that would be. So I have 149 equals, the t sub 1's drop out, 120 plus, here at least I can do a little reducing and get 12 over t sub 1 and my 10 t sub 1. All right, now let's start putting some things together. We have 120, we'll subtract that from both sides and realize, yes, we do still need to multiply by t sub 1. So we're going to multiply everything by that least common denominator of t sub 1, which makes this 29 t sub 1 equals 12 plus 10 t sub 1 squared. And that's good news because that's our quadratic. So we're going to make it a 0, 10 t sub 1 squared minus 29 t sub 1 plus 12. And we would factor this. And remember, don't be afraid to use your educated sheet to factor this. If we use the calculator to find it, we could do that. You could write out your factors. We end up getting 2t sub 1 minus 1 and 5t sub 1 minus 12. This actually wouldn't be that horrible to factor yourself. So our two zeros are 1/2 of an hour, and that one doesn't make any sense given the speed that they're driving, so we wouldn't use that. The other one is going to be 12/5 hour, which is 2.4 hours. Now that one makes sense. So it took 2.4 hours. The question was, how fast was he driving? So now if we know the time, we can go all the way back up here and we can figure out the rate. Because if we go back to this equation, which was a little bit nicer right here, we know that if we take our t sub 1 and plug it in, we can get this answer. So let me scroll back down to what we had. So let's take our 2.4. We know 120 equals rate 1 times time, which is 2.4. Divide both sides by 2.4, and the rate is 50. So it said, how fast was he driving between the place with the G and the place with the S? Well, that was the first trip that they made. So the rate was 50 miles per hour. So the rate of travel from, oh boy, Gunter Helmstadt to Schloss Meisterberg was 50 miles per hour. And there it is. that was all of the questions that you had for me off of the worksheet.